Today we're looking at similar polygons. Similar polygons have corresponding angles that are congruent and corresponding sides that are proportional. So when we're checking to see if polygons are similar, we have to verify those two facts, that the corresponding angles are congruent and that the corresponding sides are proportional. An extended proportion can be written for the ratios of corresponding sides of similar polygons. That's the A colon B colon C colon kind of thing. So if the polygons are similar, right, for the problem right here, we're going to write a similarity statement and the extended proportion for the ratio of the corresponding side. If the polygons are not similar, then we are going to write not similar. So the first thing that we have to look at is the corresponding, or comparing the angles. So comparing the angles, we can see, I've already highlighted mine so that I can read them, but you could read them. Comparing the angles, I can see that angle A and angle X are congruent. So I'm going to write angle A is congruent to angle X. And then I know that D and W are congruent, so angle D is congruent to angle W. And then Z is congruent to C, or C is congruent to D. So angle C is congruent to angle D. Angle Z. And angle B is congruent to angle Y. So all of my angles I have corresponding angles that are congruent. Then I'm going to look at comparing the ratios of the sides. So identifying the sides that go together. So my first ratio, I'm going to have AD and XW. So AD over XW, which is going to give me 4 over 2, which equals 2. Now what I need to do is make sure that all of the ratios have this same ratio value, and simplifies to 2. Okay, so then I'm going to look at WZ and DC. So the bigger bigger figure is on top the way that I wrote it, so I have to continue to do that all the way around. So I'm going to have DC over WZ, which is going to give me 9 over 4.5, which also is 2. Then I'm going to have BC over YZ, which is 8 over 4, which is 2. And then BA over YX, which is 6 over 3, which is also 2. So notice that all of the corresponding sides are proportional. So that gives me the following following extended proportion. That's going to be that AD over XW is equal to DC over WZ, which is equal to BC over YZ, which is equal to BA over YX. So I've just taken all of these pieces and written them as a single extended proportion. Okay? So the similarity statement then comes from all of the stuff that I just did. So notice that I have to, just like I did with congruent shapes, I have to line up the corresponding pieces. So quadrilateral A, B, C, D is similar. That's what that symbol right there means, is similar to quadrilateral X, Y, Z, W. There's my similarity statement. Now, let's look at this one right here. In order for polygons to be similar, they have to have corresponding angles that are congruent. Well, I can look at my two figures and see that I do not have congruent angles, so these are not similar at all. Okay, now I want you to take these, compare the angles, check the ratio of the sides, and then write a similarity statement if they are indeed similar. Pause the video and go to work. Okay, did you get that similarity statement and that extended proportion? I hope so. If not, be ready to ask me a question. Okay, now we're looking down here. The next part of this is scale factor. So scale factor is the ratio of corresponding sides. So if I look in my previous problem up here, my scale factor was 4 to 2 or 2 to 1. If I left this as a ratio, it would have been 2 to 1. So that's my scale factor. So I'm going to look at this, these figures right here. It says that I have triangle RST is similar to triangle UVW, which means that their angles are congruent and that their corresponding sides are proportional. So we're going to find out what the scale factor is, and we're going to find out what the x value is. So the first thing I do is identify the corresponding sides. I do that first by marking according to this. So R and U are congruent, and S and V are congruent. That means T and W are congruent. And then what I'm going to do is I'm going to use that information and I'm going to identify the corresponding sides. So, the side between the single and the double, and then the side between the triple and the double. Those are the marks I'm talking about. Triple marks, double marks, and then the side between triple mark and single mark. So those are my corresponding sides. So I have identified the corresponding sides. So RT corresponds to UW, segment RS corresponds to segment UV, and segment TS corresponds to segment WV. Now I'm going to write a proportion. The proportion is the larger over the smaller, so I'm going to go 4 over 2. And then I'm trying to find x, so equals, that corresponds with the orange side, so 7 over x. Always the larger over the smaller, because that's how I wrote the bigger one. That's how I wrote the first one. So then I use this information, and I use my cross products, right, because the cross products are equal. So I'm going to use that information, and I'm going to solve this proportion. So I'm going to get 4x equals 14. Divide both sides by 4. I get x equals 14 over 4. So x equals 3.5. So there's my x value, 3.5. And then my scale factor comes from here, this relationship on my sides. So my scale factor is 4 over 2. Or 2 over 1. That would be the better answer since I should simplify. Alright, let's do another one. So here's my problem. I need to identify all of the corresponding pieces. So A corresponds to N. So A and N are congruent. B and M are congruent. And C and P are congruent. And then D and O are congruent. I know that from my similarity statement. So then from there, I identify the corresponding sides, and I need the one that has the x in it. So x, this side, PO, corresponds to DC, and then BC corresponds to MP. Of course, I also have a third pair. That would be AB corresponds to MN. And it doesn't matter which other pair that has numbers, both the numbers you use. So I could either use B, C, and MP, or I could use AB and MN. It doesn't matter. So setting up my proportion, I have 5 over 3 equals 6 over X. And then I'm going to use my cross products, right? So 5X equals 18 because I multiplied across this way and this way. And then I'm going to divide by 5, so I'm going to get that X equals 18 over 5, which is 3.6. So my value for X is 3.6, and my scale factor is this ratio right here, 5 to 3, 5 to 3, 5, depends on how you want to write it. Remember, there's 3 different ways. So any of those work. Okay, give this one a try. Did you get that? If not, ask me some questions.